Okay, this is a question from Jan 11, Biol 4, in this Weinberg question. Now, before we start, previous to this part of the question here that we're interested in, there was some information telling you that rhesus negative is caused by a recessive allele. So let's look at the question. 16% of the population of Europe is rhesus negative. Use the Weinberg, so it's telling you to use it to calculate the percentage that you'd expect to be heterozygotes for this rhesus gene. So absolutely, first thing you're going to do is write down the equations. P plus Q equals 1 and P squared plus 2PQ plus Q squared equals 1. Now just as a recap, just a reminder, P and Q are referring to the frequency of the alleles in the population. P squared, 2PQ and Q squared are referring to the genotypes. P squared being the dominant homozygotes, 2PQ the heterozygotes, and Q squared the recessive homozygotes. So what's our way in? Well, we've been told 16% of the population are rhesus negative, so 16% is our Q squared. So that equals 16% or 0.16, the same thing. 16% and 0.16 is the same thing. So to get Q is going to be the square root of 0.16. So that equals 0.4. We're then going to use this equation to work out the frequency of the dominant allele P. So P equals 1 minus Q. That equals 1 minus 0.4. So that equals 0.6. We're now going to try and calculate the heterozygotes, which is 2PQ. So 2PQ equals 2 times 0.4 times 0.6, and that equals 0.48. Key thing here is that it's explicitly told you to calculate the percentage, so to get the full marks you need to turn that into percentage, which is 48, and all I've done to get that is multiply this by 100. So there we go, 48% of the population you'd expect to be heterozygotes for rhesus negative.